Ladies and gentlemen, and welcome to a new episode of the series. And today's project is a color, interpolator, and triangle rasterizer, as you can see. Very, very beautiful. It looks so nice. Anyway, just a little bit of background on this project. Well, you can see this very nice looking triangle. I love looking at it personally. I don't know about you guys. Anyway, some stuff about this triangle. This triangle is written using an API that I made, and the color interpolation and everything is done by me. The animate triangle function actually specifically is done by some outside resources, some are intelligent resources specifically. But that all the API is written by me, and it's using for color. It's using ANSI 24-bit true color escape codes. So that's how that works, and every single pixel will store each an RGB and RG and a B value. Now, as you can see, we use @ signs to actually output to the screen because they take up the most space. I might use space characters later, but that's not the really the concern right now. In any case, here is the triangle. And this API can also do other stuff. It can draw colored rectangles, colored lines, colored straight lines. It can do a lot of other stuff, and I'm planning on making it can draw normal polygons and convex polygons right now, but not colored yet. I'm planning on making that a thing eventually. It's quite easy because I already have the colored triangles down, so it'll just be a matter of actually just like changing a few types here and there for the actual function. In any case, enough of talking. Let's look at the code. So here's the code that's actually running on the screen. Yeah, this is going to keep on running because I don't know why. This is the actual code. You can also animate a pentagon if you want. I don't think it works right now. I'm not sure why though. So here is it. And we're going to talk specifically about rasterizing a triangle today. So I'm not going to try to go too in depth with it, but I'm going to explain the basics of interpolation. As you can see, I've already tried doing this before. I did not cut the video because I didn't like it. Anyway, so the first method that you could do, right, is, can I zoom in on this? I cannot. Is this method over here. All right, so you basically create a bounding box around the triangle, and you iterate through every single point inside the bounding box and see, oh, hey, is this point inside the triangle? There's a formula for that, by the way. There's a mathematical formula. Use that formula. Say if this point is inside the triangle, then plot it. If it's not, then don't plot it. That's very slow, right? You test every single point, and if the triangle is something like this, where it's like basically maximizing the size of the bounding box, it's not very efficient. There is in fact a better way to do it. First, let's figure out how to be able to fill in flat top and flat bottom triangles, right? So how do you fill it in? Interpolation. So interpolation is basically where you have 2 points. You have a line segment defined by 2 points, and let's say you wanted to get a y coordinate on. Let's say you have a line segment defined by 2 points AB over here, right? You have line segment AB, and let's say you want to get the x coordinate of a corresponding y coordinate somewhere on that line segment. So we have the y coordinate file over here, and let's say we wanted to get the corresponding x coordinate. Interpolation, it's a mathematical formula, again, would give us the x coordinate, okay? That's how interpolation works. So how we would use interpolation for this is we would go, this is C, actually no, this would probably be A, this would be B, and this would be C. So we would start at the top BC, right? And we would draw a line from point B to point C, a straight line, because straight lines is a lot more efficient than drawing of lines with a actual slope that is not 1 or undefined. So drawing this line over here from B to C. Now we go down, up a y coordinate or down a y coordinate, depending on how you look at it, because the top left is 0, 0, not the bottom left. For you math people out there, let's say we go down a y coordinate. All right, we increase the y coordinate. Now we're on the second row. We use interpolation because we already know the y coordinate, which in this case would be 1, and we use that along the line so we can BA to find the corresponding x coordinate over here to find this point. And we do the same thing over here with C and A to find this point. And then we just draw a straight line from this point to this point over here. And we keep on repeating for the rest of the triangle. And we could do the same thing in reverse for flat for flat bottom triangles. It's pretty simple. Now, how do we split a regular triangle into a flat top triangle and a flat bottom triangle? Because every triangle can be split into a flat top triangle and a flat bottom triangle, except if they're already a flat top or flat bottom, which of course we can detect. First thing we do, we get the points and we order them by height. What do I mean by that? Lowest y coordinate goes at the top, highest y coordinate goes at the bottom. That's it, like that, okay? So now we have A, B, and C. We have A, B, and C over here, right? And they are ordered. Now what we do, we have to find out which side the bend is on, okay? So we can see that the bend is on this side, but how does a computer tell? Well, what the computer can do, as if we, oh wow, it's still going, as if we look over here in the draw try function. if point B's x is greater than point C's x, if point B is basically to the left of point C, that's how you know the bend is on the left side. And if the bend, right side, my bad. The bend is on the right side. And if the bend is on the right side, then what you can do, you can use interpolation to find out the x coordinate along the line defined by segment AC, corresponding with the y coordinate 10 over here. So you can draw a straight line over here, and you can use interpolation to find this x coordinate because you have the line segment AC and you have these 2 points, right? Like I explained earlier. And we can draw a straight line there. And now we have a flat top triangle and a flat bottom triangle. And if the bend was on the other side, let's say in a triangle like this, if point B is less than the coordinates of point C, if point B's x is less than point C's x, then what we can do is we draw it from point B to this over here. We just draw it the other way around. And it's still the same thing. We now split into flat top and flat bottom. Now, color interpolation, now this works for filling in triangles of a single color because we don't handle color anywhere in this thing. So how do we handle color? Now, there are multiple ways of doing this. Mine is probably not the most efficient, but it's the one I thought of, so it's the one that I'm going to use. I'm obviously going to implement a faster way in the future, but this is the one that I'm using for now. It's quite fast because we don't have to interpolate for every single point, unlike some things. So what we do, we split it into the top and bottom, right? That's negligible. We don't have to do that. And for the top thing, what we do is we interpolate, is we find the color along this line. So we find the color along this line. So we have, there's a formula for that. So let's say you had 2 points, B and A, and you wanted to find on point P, and they both have a color channel, you wanted to find the color values of point P, PR, PG, and PB, if you get the x and value of P. And you can do that along a 2D line. So you get the color values of all these points over here, and then you get the color values of all these points over here. And then we do the same strategy, similar strategy. We just draw a color value, we draw a line from over here to over here, and it'll blend it in for us. As we can see over here, what we do, if we go into fill flat top, right? We calculate all these color stuff that we need, and we get the lerp factor, and what it really is doing, right? We start this is fill flat top, so it'll be a flat top. We start at the top, and we keep on going to the bottom, which is going to be A. And what we do is we just draw, this is the left coordinate, as we can see, we increase A to left, and yeah, so we just calculate the, that. I always say horrible explanation, I understand, but I'm really not the person to look for an explanation for this stuff. I'm just showcasing my projects. If you want an actual explanation, please go check out some other resources. I'll try and link some in the description. But that's it for now. Thanks for watching, and have a great day.